Here is question number 26, everyone. If length of fixed metallic wire is 3L when force of 200 Newton is applied and 3.5L when 250 Newton is applied, the natural length of the wire will be what? Now we know very well that the force acting on any wire, if it is stretched by a length x, is given by F equals kx, where k is known as force constant. So from here we can write x equals F by k. Now let us consider the actual length of wire is L0. So we can write 3L is what? Stretched length plus actual length. So what will be the stretched length? That will be 3L minus L0. This is your stretched length x, which is equal to F by k, that is 200 divided by k. Equation number 1. Similarly, if 250 Newton is applied, then the length of wire becomes 3.5L. So we can write 3.5L minus L0, that is x, equals 250 divided by k. Equation number 2. Now dividing 1 and 2, we get 3L minus L0 upon 3.5L minus L0 equals 200 upon 250. That is 8 by 10 or 4 by 5. Cross multiplying will get us 15 times L minus 5L0 equals 14 times L minus 4L0, and after solving we will get the value of L0 equals L. So therefore the actual length of the wire is L, and we will go with option number 1. Move on to the next question, that is 27. Now here we have question number 27, everyone. When a force F is applied on a wire of uniform cross-sectional area 5 mm square, length 4 meter, length of the wire increases by 0.1 cm, then energy stored in the wire will be what, given that Young's modulus 10 to the power 11 Newton per meter square. Now we know very well the energy stored in the wire, that is elastic potential energy, will be given by half of Young's modulus multiplied by strain square multiplied by area of cross section multiplied by original length of the wire, and every data is given in the question. So putting all the data into the expression, we will get 1 by 2 into Young's modulus, that is 10 to the power 11 multiplied by strain is change in length upon actual length. Change in length is 0.1 centimeter. So we can write 0.1 divided by 100 in meter divided by actual length, that is 4 square, multiplied by area of cross section, that is 5 mm square, and we have to convert it into meter square. So 5 into 10 to the power minus 6 meter square multiplied by L, that is 4. Now after solving we will get 5 by 8 into 10 to the power minus 1 joule, but options are in millijoule. E will be 5 by 8 into 10 to the power minus 1 into 10 to the power 3 joule, and when we solve it we will find that E equals 62.5 millijoule. Option number 2 is absolutely correct, so option number 2. Move on to the next question, that is 28 number. Here is question number 28, everyone. A solid body is floating in water, has 3/4 of its total volume immersed in it. What fraction of its volume will be immersed if it floats in a liquid of specific gravity 1.5? Now let us consider the volume of object is capital V. Now the amount that is floating will be what? 3V divided by 4, and since it is floating, so forces are balanced, therefore the weight of object, that is mg, will be buoyant force, that is 3V by 4, volume inside the water multiplied by density of water, that is 1, multiplied by acceleration due to gravity, that is g. GG cancel out, and we have got the value of mass in terms of volume, that is 3V divided by 4, equation number 1. Now if the same object is immersed in liquid of specific gravity 1.5, or you can say relative density 1.5, then what fraction of volume will be immersed? Suppose V dash is the fraction of volume immersed. Now we have to calculate V dash. Again, since it is floating, therefore forces will be balanced. So weight of the object will be balanced by buoyant force, that is V dash into density 1.5 into G. In CGS system, the relative density will be same as the actual density. So that's why I have written directly the relative density. GG once again cancel. Mass has the value 3V by 4 equals V dash. 1.5 is 3 by 2. So 3 cancel, 2 2 ja 4. From here we can see that half volume will be immersed in this liquid. So we will go with option number 1, 1 by 2. Move on to the next question, that is 29 number. Here is question number 29, everyone. A plank is kept on a smooth horizontal surface. A uniform disc is kept on the plank and the plank is pulled by a horizontal force, capital F, as shown in figure. If magnitude of acceleration of plank is AP and magnitude of acceleration of center of disc is AD, and there is sufficient friction between plank and disc to avoid the slipping, there is no slipping, then which one will be the correct option? Now since there is no slipping and a force capital F is applied on it, it means the acceleration of the center of mass will be in this direction, which is given AD. Now we can write, since friction is sufficient to prevent slipping, therefore acceleration of center of mass of the disc AD is towards right, and the angular acceleration of the disc will be anti-clockwise in sense. Angular acceleration of disc will be anti-clockwise in sense, or we can write out of the plane of paper. Out of the plane of paper. So therefore the acceleration of the bottommost point will be what? The acceleration of bottommost point, now we can write there must be AD as well as there must be acceleration due to angular acceleration. So A will be what? AD plus R alpha. This will be the acceleration of bottommost point, and it is clearly mentioned in the question that there is no slipping occurs. It means the acceleration of plank must be also the same, that is A. Now AP we can write AD plus R alpha. So it is clearly, now we can say that AP will be greater than AD by R alpha. So gentlemen, AP is greater than AD, or you can say AD is less than AP. Acceleration of disc will be less than acceleration of plank. We'll go with option number 1, which is absolutely correct. Move on to the next question.